Hi, hope you're well. I'm Jadi and we are going forward in LPIC. We're talking about managing shared libraries. Where it is 1, it used to be 2. They're reduced its importance. It's important. It's poor managed shared libraries. And hackers use it to run executables they don't have permission to execute. I will show you at the end. Not to keep the tension alive, but because logically it comes at the end. Let's go. Objectives is candidates should be able to determine the shared libraries that executable programs depend on and install them when necessary. Installing will be discussed mainly on the next part because we will speak about how to install softwares in Debian-based and Red Hat-based systems. But here we will know what libraries are needed. We should be able to identify shared libraries, identify the typical locations, and load them. Also, we should know about these terms and utilities: LDD, LDconfig, LDSOConf, and LD library path. But first, let's understand what is this shared libraries and linkings. The point is, when you are writing programs, you never write everything by yourself. At least I never. Depends on who is the programmer. We always use other people's programs, routines, softwares to write our own program. Say I want to write a download manager. I need a graphical interface. I should be able to insert links here and push the download button. Okay, I have to create this graphical interface. It's very, very, very difficult to create it from scratch. But there is a library which is called, for example, LPIC1. This is dedicated to creating graphical interfaces, buttons, windows, whatever you need, input texts. So I will use LPIC1 to create this window, to create this input, to make it possible to push a button here, to show a progress bar here, and whatever I need. Then the person enters the library, I push this, so I need to go through the internet, send a packet, read a packet, check if it's HTTPS, I have to negotiate it, whatever, if there is a username, password. It's very difficult to write for FTP, Telnet, HTTP, blah, 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 blah. So I will use libcurl. Curl, you may know the curl. Curl is a program command line interface where you can download things, you can get resources from the internet, from the network, whatever. Libcurl is a library of curl. So I will write my program which uses libcurl to create this interface, and then when someone pushes this, I will call libcurl with this URL to download the file. But I want to package my software and give it to other people. There are two ways: static and dynamic libraries. Practically, the process of adding this to my program and run this is called linking. I have to link these libraries to my program. I can create statically linked software. I will create a huge package which contains all the Qt, all the libcurl, and my software, and will deliver this to people and say, okay, just run it. It has whatever it needs and it will run smoothly. Very nice. Another method is using dynamic packaging. When doing dynamic packaging, I will just provide this small program I've written and I will tell it needs Qt and it needs curl to run. This is dynamic. As you can see here, it's static because all the libraries are here. I have libcurl, I have lib blah blah, and I have my own program and all other libraries I need. Here it's called dynamic because I only provided my program and dynamically it needs other libraries. So what are the advantages of dynamic packaging, which is a preferred one in Linux world? Static looks better. It's easier to run. It has whatever it needs. But there are problems. First, this Qt library might be 500 megabytes. So your package will be 650 megabytes because it contains all of this and your program. My package here might be 2 megabytes because it's a small program which just calls this. So much better one. Especially if you have 5 different programs which all use Qt, you will have 5 different 5 megabytes copies of Qt because each of them contain its own Qt libraries or whatever libraries. This is bad. First. But the more important part, say the very cool guy who's developing curl finds a bug here. So he fixes this very severe security bug. What happens in this case? This specific programmer should create a new package with the new fixed curl, provide it to you, you update, and this will be fixed. But this one is not updating his program anymore. This one, she's just forgot about it. This one, it is going to do it 2 months later. And this one, you don't even know that it's installed. So all of these are vulnerable to the new problem. In the dynamic style, it's much better and much safer because it's enough that you do an update on your operating system. We will see this on the next chapter. And curl is updated. So whatever program which is dynamically uses this curl will be safe. This is why the dynamic method is better. Even this libqt might add a new cool feature to its program. Just as soon as you update this specific library, whatever program you have installed and using the Qt will have this feature. In this case, you have to update each software separately. For different reasons, dynamic loading is better. Also, think about the memory. Here, you have one libqt in the memory and everyone uses them on disk or memory. Here, each program will load its own libqt with a different version somewhere. Still, there are good points and bad points. Using static ones is easier because it just works out of the box. You don't need dependencies, but this is not a big deal anymore in Linux world. We will see in the next chapter. Linux libraries do look like this and are copied here most of the cases. Let me go to my Fedora, run a console. You remember ls here, you know most of these directories, and we have one lib directory and one lib64 directory. This contains 32-bit libraries. This contains 64-bit libraries, and we are on a 64 computer. So if I go to the lib and the 64-bit operating system is installed. If I do a ls here, nothing much here. If I go to Mozilla here, even if I go do a tree, you can see that nothing installed here, only some directories. You may need to install tree by yourself. I will show you on the next chapter. But if I go to lib 64 and do an ls here, you will see lots of directories. For example, lib kpm core so11. This is library, the name of the library. So is the general extension. In Linux, we don't have such thing as a hard extensions like we have on the Linux. It's just a convention, and this is the version. For example, this one, lib krdc core so, and this is the version. This is the major version. So we are using krdc core 21, and this is the minor versions. If they add features, they will move this to 13. If they fix some bugs, they will move this to 3. This is just a convention, not a rule. So here we have the libraries. As you saw, they were in /lib and /lib64. We also have, as you know, /user. And here we again have lib and lib64. On the /lib and /lib64, mainly system-wide, the libraries which are used by system utilities are here. When softwares install themselves, for example, if you install MySQL, those libraries will go on the user lib and user lib64, just to separate things to some extent. So these are 4 places we generally find our libraries. There are more, but I will show you a bit later. But let's go and see how we can check what libraries are needed for each program. This software is called LDD. LDD tool will show you which libraries are needed. For example, for ls, I will check the ls and say what libraries are needed to be linked for this to run correctly. It says, okay, if you want to run ls, it needs this library, this library, this library. It needs libc, also it needs lib this, and ld linux. If I do the same thing with LDD, a utility like user sbin ldconfig, you will see ldconfig a little bit later in the same chapter in 5 minutes. It will check all the libraries and create a cache of the libraries. It says this program, unlike ls, is statically linked. Why is that? There is a good reason why in the Linux world we decided to statically link ldconfig. The reason is cool, not obvious. The point is, as I told you, this program checks all the library locations and create a cache of the libraries. So other programs can just look at the cache and load the required library. So if this is not statically linked and it needs some libraries to run, and there is a problem in your libraries or in your cache, this won't run. So you need this to fix the issues with the libraries. So the ldconfig file is statically linked, has whatever it needs inside itself. This was LD, and we speak about one more important thing. Say I'm a programmer. I'm writing a program for udev. You know about the udev from previous sessions. So udev, I need udev library version 1. I'm writing some softwares. I don't know where it's going to be run, but I say I need udev version 1. So the file should be libudev version 1. But this is a major version. When I'm working on my operating system, I might have, for example, libudev.so1 version, for example, 7, and the minor version 2, because the developers of udev are working on version 1. They add some features, so they add this number, and they fix some bugs, so this number is moving. But the programmer who's writing this software doesn't know about different minor versions, whatever. He just knows that I need this, or she, that I only need the version 1. So how we can resolve this problem? Program cannot know about this, and on operating system, we should be able to upgrade this after a bug to 1.7.3. What should be done? Different distributions solve this by short links. You will see about short links later in other chapters. But short linking is like creating a short link, creating a pointer, creating a soft link, creating a pseudo name for another file. So what they do is they actually install this on their computer, on your computer, and then create a file with this name and short link it to this. So if a programmer says I need libudev so1, the operating system should provide this. But operating system actually installs this on the disk and creates a link from this file to this file. Later, when you do an upgrade, you replace this file with lib udev 1.85. And then operating system, your distribution, will link this file to this new file. Still, the programmer says, I need version 1, so it will load this. This is a method to resolve this problem. If I say locate lib udev so1, locate will show you the location of the files. We will see them later. Lib udev so1, it says, I found 2 files with this name. One is this one, the other one is this one. And if I do a lsltrh, show me long, on that file, it says, Jody was right. This file is a link to actually this file. So even if I upgrade this and upgrade this to SO1815, again, I will short link this to this one. So the programmer can say, I want version 1, but actually it will use this version. So this was another interesting concept which you should know. Let's speak about the cache, but first I have to resolve the issue and see why my line has become stronger. And now this is good. Okay. As I told you, the libraries are in /lib and /lib64. Also /user/lib and /user/lib64. But you can copy your libraries in another places too. The main configuration files, as you can guess, is in etc. So if I do a etc ld/soconf, I can add many names, directories here. For example, I can say also use, I can add a line here, just forget about this line. I can say etc lib, which is a strange place because etc should contain configurations, but no problem. I've told Linux and Linux will obey. Var check will check every part here. So I can add different directories to this file and tell the Linux to search these too. But this is not a good practice. You will see this pattern in many places in Linux configurations files, in especially recent configuration files. What was the problem? We had a configuration file for all the libraries. There might be some directories here. I wanted to add mine. I would add mine here. You would add yours here. And this file would change. Then you needed to update your operating system. This file might be needed to be replaced by a new file. Your changes will be lost. Later, someone might doing a troubleshooting of the system and they didn't know that you added this, that I added this. They wouldn't know if this is a legit one, if it's coming from operating system. You would mix your configurations with operating system configurations. So many configuration files are updating to this format. They say in the main configuration files, you can have something, 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 and you can have an include. This configuration file will include all the conf files in this directory. So if I wanted to check what are the actual configuration files, I would say, okay, the main configuration files is pointing to ld/soconf, all configuration files there. So let's check that one. I can do a ls etc. Here I had my main file, but it says check here. So I can check there. ld/soconf, it's a convention to say point d/, and you can see I have different files here. We can again check one, say etc ld/soconf d, and LLVM, for example. It says check this for the libraries I needed to add. See what happened? They could have put this directly here, but instead they said in the main configuration files, I'm telling you just go to this directory and check whatever .conf file is there. There are 2 files. So read all of these and add these to your library locations. Now, if I wanted to add something to this configuration, I would just create a new Jody conf file here, and I would add my directories here. So when the system was updating, it could update this, update its main files, and mine would remain intact. Or another user would see that, oh, this is added by Jody. This is a very good practice. So now we saw that we have a file here which points to this directory, and whatever file here will be read and new location files will be found. But it will be super slow if each program you wanted to run would tell Linux, okay, go check this directory, check that directory, see what files we have, and load this one for me. So we have one config with one command. It is called ldconfig. Let me run it without sudo first. ldconfig will read this configuration files, will proceed this configuration file, will proceed to all other places wherever it can find libraries, and would create a etc ldso cache, and this contains a cache of find this library in this location, find this library in this location. So if you are running an ls and it needs libc, it will just look into the cache and say, okay, libc should be used, is provided by this file, so go and use this file. So when you run sudo ldconfig, it will read all the configurations and it will create a cache of all libraries. You can also do it with -v. V means verbose, speaking too much. So we'll show you, I'm doing this, I'm doing that, I'm doing this, I'm doing that. In some programs, /-v is for version. In ldconfig, capital V is for version. Small v will show you a verbose version. So ldconfig will run, will read all the configuration files, will read whatever config it can find, and will produce a cache which says, okay, if someone was asking for libgl, you have to load this file. You can also look into the cache and by ldconfig-p print. So it will print whatever is inside this cache. So when you're changing your configurations or adding libraries, you have to run ldconfig once. When you are installing programs, they will run ldconfig in most cases if needed. So you don't need to run it manually unless you add more libraries and you need to tell it to add them to the cache. And that was it. And at the end, not end, but one more thing to say, 2 more things to say. I have to show you where OS finds dynamic libraries. When you run a program like ls, as you saw, it needs some dynamic libraries. First, it goes to the ld library path environment variables. You will see them on next chapter about environment variables. But if you have defined something like this, it will check this place and see if the requested library is there or not. Then it will look into program's path, where the program is running from a path. You will speak about the path later, but it's another environment variable which tells Linux where running programs can be found. So it will check all of them and they're separated by a colon. I can show you. If I say echo $path, it will show you the path environment variable. So if it says, if any command is issued, if someone said ls and push the enter, first look into home jody.local bin. If it's not there, look into this place. If it's not there, look into this. If it's not there, look into this. Same thing happens with your libraries. If a library is needed, check here. If it's not there, check here. If it's not here, check here, check here, check here, check here. So first, see if we have this variable. If it's there, check this. In most cases, we don't have this variable. So it will check the path. Then it will check etc ldsoconf as we talked. And ldsoconf may point to ldsoconf d in its beginning or its end. In our case, it was the only line it had. Then it will check lib, lib64, lib, user lib, and this one. Why we may need this? The fun thing is, yesterday I was working on libcurl. I compiled my own libcurl. I needed to run libcurl using my own library, not with the system libraries. So I could set ld library path to the location I compiled this and then run the curl. It would use this one. This is why we have this option. So sometimes you're writing a program and you want to use one specific library you are working with. Or you are running an old software which needs an older version of a library. So you can copy that older version somewhere and run your program with the ld library path. And another scenarios. If you want to add an environment variable, this is the way to go. You say export ld library path equals this path colon this path. So if I run any program now, first, and it needs a library, first the system will check this, then we'll check this. Then we'll check whatever is in the paths, as you know. Then it will check, the whatever is in these configurations, and at the end it goes and check these places. And this is the last part. This is not part of the LPIC, but it's good to know, and hackers use it. As you saw, when I have user lib ls, user bin ls, this is the ls command and I can run it normally. Okay. If I do ldd user bin ls, it shows me which libraries are needed to run this program. But I can run linker manually. Linker used to be called ld or ld linux. I cannot run it directly, but I can do a locate ld linux, and it's here. User lib64, this is the Linux linker. So I can say use the linker on the ls command. It will check inside this library, this command, will see what is needed to run this, will load those libraries if not already loaded into the memory, and then execute this, and if needed will link them to these libraries. So this is another method to run a Linux executable, using the linker to run an executable. See? This is fun. But a good question is how the program is run when I directly type its name. This is too deep, but let's have a look. I can do a file on any file. File will tell you what file this file is, what type of file. If I do a file, user bin ls, it will tell me this is a elf executable. Elf is a Linux executable. This is an elf 64-bit executable on Intel compatible processors or AMD compatible processors. Cool. But what happens when I directly run this? There is a program which is called readelf. I will say show wide, show the headers, and open this file. I will say what is written in this elf file. It will tell you lots of things. Especially, it will tell you that your ls executable, which was an elf, if you check its content as an elf executable, its interpreter is lib64 ld linux linker. So if someone wanted to execute this file, check inside, and it's an ELF. So requesting program interpreter is the Linux linker. That's why how you can run this program without directly calling the linker on it. This is so cool. What is cooler and what hackers use is if you have a file which is an executable, but the executable permission is not set on it, you have a way to run it. We will talk about the permissions later, but you can have an executable file without an executable permission. So there is a file somewhere on the system which you cannot execute officially, but you can execute LD Linux. So you can tell the Linux command line to run LD Linux and link this file. You only need read access. You don't need execute access. So if you have execute access here and read access on this one, you can execute this program. This is how hackers execute executables which they don't have execute access on. This is so cool. If you are not familiar with these execute flags, we will cover them on next sessions in LPIC. But let's first go to install software. I was Jody. Sorry this was long, but if you want to learn deep, you should spend time. Hope you liked. I am sure less than 1% of the people who use Linux know about this link. Have fun, subscribe, tell your friends. That's the only hope I'm doing this for free.